I won't.
I won't have. I'm pretty close though.
I'm surprisingly close. I think it might take a bit longer. 2 weeks.
All right, we're back to linear motion. So position, velocity, acceleration, and all the things.
Sure.
So number 2, these give us, it says the function v of t is the velocity function in meters per second of a particle moving along the x-axis. Use analytic methods to do each of the following. A, determine when the particle is moving to the right, to the left, and stopped. So v of t equals 6 sine of 3t. 0 is less than or equal to t, less than or equal to pi over 2. So part A is particle moving left, or right. I cannot do this. Right, left, or stop.
You said right just then I thought you were like asking us, like, right? Maybe.
All right, so we're going to take the 6 sine of 3t, and because right now we're dealing with velocity when it's moving right, left, and stopped. So to deal with stopped, first of all, we're going to take the function 6 sine of 3t and set that equal to 0. So sine of 3t equals 0. Now, where is the sine of t, or where is sine equal to 0? And so I'm going to take 3t and set it equal to 0 and 3t equal to pi, because if that's the case, that will make sine 0. So t equals 0 or t equals pi over 3. So this is where it is stopped. So now I've got to...
my paper folder.
Oh, so now I've got to break it into intervals from 0, less than t.
I just went. So Virginia and I were having a little debate. I just remember this. Is that a shadow or a reflection?
Well, I said the tree is reflected onto the whiteboard.
I don't even know what you're looking at.
That little like square where you can see the tree outside the window.
I can't see the tree outside the window.
Here, let me. I see it from here. Here, let me circle it.
I see the Christmas tree. I see the closed blind, the popcorn buckets, and the sign from Homecoming.
On the board? How?
I don't see a tree.
You
Do you
like
see the thing that's
branches
moving around?
Do you see it?
No,
moving?
nothing is moving.
What?
Oh, come here.
It's like you can see the branches moving around.
Yeah.
Yeah, I can't see that from over there at
Is that
all.
a shadow or a reflection?
Well, it's reflecting.
I
onto
say
the
it's a shadow.
whiteboard. It is a shadow, but it's reflecting onto
But
the
it's
whiteboard.
not reflected. It's, I don't know, projected maybe, but not reflected.
Well, you
No, I didn't.
yes, you did.
Use the right terms next time.
I would say a shadow just based on where it is.
See, I told you.
Well, I
And
meant
where the
that it
sun
was,
is.
like going onto the board.
Right, it's not reflected.
Well, I tried my best.
It's projected, like the thing on the board up there. You know, the things that she's writing. Those are projected.
We'll find out when we get to light and reflections in
True.
chapter 13 and 14. All right, so I have to break this up into intervals now because if we did like our little sign chart type thingy, right, we would find out what's happening here. So essentially, you don't have to draw it as a sign chart. If you want to, you can. It's up to you. I don't necessarily do the sign chart, but we did when we did this stuff earlier in the year, so it's just kind of however you want to do it. So I usually just pick a number in between here, so say pi over 4. So I've got 6 sine of 3 pi over 4. What's the sine of 3 pi over 4?
Root 2 over 2.
So this is 6 times root 2 over 2, which is 3 root 2. And then I've got v of y, 5 pi over 12. Now, do we know that value? But am I going to know it when I plug it in?
Yes.
Yes. Because this is going to be 6 sine of 3 times 5 pi over 12, which is going to become 5 pi over 4. It's the sine of 5 pi over 4.
Root 2 over 2. Wait, negative.
Negative. So this is negative 6 root 2 over 2, or negative 3 root 2. So the one that is less than 0 is going to the left. Stop that. The one that's greater than 0 is going to the right.
Wait, where'd you get the 3 from and the 6 sine of like 3 times?
Because it's 3t, and this is t. 5 pi over 12 is t, so it's 3 times t.
The v of t was 6 sine of 3t. That's where that
Oh, so there was 2. Wait. Oh, so in the first one we just used pi before, but then we multiplied it by 3. Oh.
Yeah, because I could with that one in that interval, but from pi over 3 to pi over 2, I don't technically know a value, right? Like there's no known values to me, but 5 pi over 12 will reduce into something that I do know. So this is right, this is left. Now to sum everything up, which we would ultimately want to do, I would say from 0 less than t less than pi over 3, it's going to the right. From pi over 3 less than t less than or equal to pi over 2, it's going to the left. And at t equals 0 and t equals pi over 3, it is stopped. And I would pretty much guarantee on the AP exam you're going to end up with some question that's asking you some sort of information like this. I would say as a free response question. Whether it be exactly this or something like similar in nature, I would just be prepared for that.
You know, with free response questions, we also have free will, so what if you just said no?
You won't do very well in the exam.
Right, but I mean, I'll still do the work, but I might protest it.
Protest it after you're done. Part B. Find the particle's displacement if s of 0 equals 3. What is the final position? So if I have velocity and I need position, what do you think I should do? Yep. So I'm going to have 6 times the integral from 0 to pi over 2. That was the initial interval given to me of the sine of 3t dt. How would I solve that? Let's see how much you know.
I mean, I was kind of thrown off a little bit when you threw in that integral there. I was just gonna go straight antiderivative. I know it's a chain rule though. So
Okay. How do we solve chain rules?
that's
It was on your last test.
negative 2 cosine of 3t.
Where'd the 2 come from?
Because the derivative of 3t is
3.
3, so put the 3 with whatever was out front, which had to be negative 2, and since it's sine, it would have been cosine.
I got the negative cosine. That's as far as I got them.
You might have happened into the right way to get, or not the right way to get there, to the right answer, but definitely not with the right method.
Hey, got there somehow.
You look so
Got
confused.
further than me.
How about let u equal 3t and du
That's so much more difficult.
equals 3 dt. So then 1/3 du equals dt. And how about u equals 3 times 0, which equals 0, and u equals 3 times the pi over 2, which equals 3 pi over 2. So I can redo my integral as 2, because it would be the 6, well, let me do it this way. 6 times 1/3, and then the sine of u du, but the things will go from 0 to 3 pi over 2 now instead. I wouldn't have to do it this way, but it's a little easier. And then I've got negative 2 cosine of u from 0 to 3 pi over 2, which is negative 2 times the cosine of 3 pi over 2 minus the cosine of 0. Just negative 2 times negative 1, which is 2, is my displacement. Is that what you got?
No. I just went your route, followed you along for the ride.
Wait, so why did I get everything except for like the where we plugged in the numbers like for t, like the why we did that, like we plugged in.
It's a different method that we used like way back when. But you could have also just left them as they were, and you would have had to plug in 3t again. I basically just already plugged in the 3t instead of replacing u back, because notice I never replaced u back because I changed the
Because you
dimensions.
already have the other u
And so
equals.
it would have just been like negative 2 cosine of 3 times whatever.
3 times the
So we
original.
can still do it that way.
Yeah, so I could have instead done basically 6 times 1/3 times the integral from 0 to pi over 2 of the sine of u du, and then gotten down to 2 times, or negative 2 cosine of u, and then changed that into negative 2 cosine of 3t, and then kept going. This was just a different way that we had done way back when that I was kind of doing more as a refresher, but either way, we'll give you the same answer. Is this what you said is the antiderivative, though?
Yeah, basically. Except I didn't have the u, I had the 3t.
Well, right, okay,
Yeah. Because it was a chain rule thing.
right. So this is the displacement, but we're not done. New position, and this is only part B. equals initial position plus displacement. The initial position was 3 from the S of 0 equals 3. Plus the displacement of 2 is 5. So our squirrel went 5.
At least that little part wasn't as hard as I thought it was about to be. You were like, there's something else. It's like, oh man.
But wait.
There's more.
Oh my goodness.
Find
We
total
have 40 seconds left of class.
distance
Thank you, Belle.
traveled by the particle.
I don't know. I feel like the bell just stays off of me.
Basically, we'll actually run the integrals tomorrow. We're going to have the integral from 0 to pi over 2 of v of t equals the integral from 0 to pi over 3 of 6 sine of 3t, which I would actually take this 6 and put it out front, minus 6 integral pi over 3 to pi over 2 of the sine of 3t dt. And then I would work these down to get the final value.
Wait, is that
Because remember, displacement and total distance are different.
so? How many DTs are we supposed to have? Just one total?
No, over here there's supposed to be 1, 2.
Okay, and how about the V of T?
I don't have that one written. I don't think you need it on that one. This is technically the problem. I was just showing what it's equal to at the end.
Okay.
I mean, I'm sure you can have it, but technically speaking, in my things, I don't have it there, so. But we'll finish that down. If y'all both finish your physics test, we may finish this problem just so that it's done. But basically, we would just take these integrals, integrate all the way down, and we'll get it. And our total distance is most of the time going to be different than our displacement, as we have seen prior with our squirrel.